Good afternoon, Miss. My name is Nell Chong, and we are from Group 7. My group member is Evan Sojourn, Ebonian, and also Fu Fang Rong. Our assignment title is Smart Hospital Management System. In this video, we are going to presenting our work for this assignment. Firstly, I'm going to presenting the breakout of smart hospital. The concept of a smart hospital encompasses healthcare practitioner employee advanced analytic, connected device, and healthcare platform to improve treatment, productivity, and operational efficiency. Smart hospital use data and AI insight to help with decision making at every step of the patient experience. It has the potential to provide medical personnel with insight that allow for enhanced and more rapid care. Smart hospital also improve the work of healthcare professionals and hospital management, such as tracking hospital bed occupancy, tracking patient vital signs, and evaluating radiology scan. Next is about the history of the hospital. The first medical record appeared in the 1920s. The origin of the health information management sector can be tracked back to the 1920s when healthcare professionals began using medical records to track patient treatment details, difficulty, and outcome. In order to organize the information used in medical records, the first problem-oriented medical record was developed in late 1916. Many healthcare information management systems were developed as a result of technological developments in computers in early 1970. In the 1918, the master patient index were created to keep track of patients and their medical data. This opened the path for Indiana Health Information Exchange to administer the Indiana Network for Patient Care. Next, I'm going to present the objective. So first, the first objective is to detect the bed ID, pressure, temperature, and timestamp of the bed. There is an IoT sensor to detect the data of the bed to determine whether the bed is occupied or unoccupied by a person based on the data. Next is to identify the bed's status by installing a camera on the bed. The camera will capture a video or picture of the bed, then send to the cloud and generate an output about the status of the bed. Last is to send an email to notify the hospital management about the bed status. It will send an email about the information of beds to notify them which beds are available or unavailable in the hospital. It helps to improve the patient experience and save time. That's all for me. Now I would like to pass to my member to present his part. Thank you.
I'm Fu Fang Rong. I will talk about the problem statement for this project. The hospital or healthcare industry nowadays has played an important role in the world to ensure that they can provide quality care and patient experience, especially during the COVID-19 pandemic. Firstly, one of the problems is many of the hospitals are unable to manage the huge volumes of their patient-related data. One of the most intimidating parts of healthcare is the amount of patient-related data. The patient database continues to grow as more patients are added, adding to the total amount of data available. The second problem is the hospital lack of real-time situation management without the help of technology. The hospital management system that they do not give access to real-time metrics that could speed up responses and produce better results, such as the number of beds that are available at any given time in a facility or the location of the vital supplies. Furthermore, the problem is efficiencies and errors in data sharing. Despite notable improvements in medical research, the management of traditional technology used in the healthcare sector has led to ongoing inefficiencies and healthcare blunders. Because of the waste it produces, this is more than just a challenge for medical science. That's all for the problem statement part.
Hi everyone, I'm Elton. I'm going to present the demonstration of this project. I'm going to present the S3 bucket, Amazon Reconnection, the 2 Lambda function, DynamoDB, Amazon SNS, and finally the end devices used by the hospital management. The camera will representing the CCTV installed inside the patient room, and it will capture the image with the bed and store it on the S3 bucket. When there is a new image uploaded to the S3 bucket, the first Lambda function will be triggered and send the image to Amazon Reconnection, and the reconnection will return the result to the first Lambda function, and the Lambda function will take the result and invoke to the second function. The second function will be containing the IoT sensors information and combine it with the bed status together and store into the DynamoDB. After that, it will also send the information about the bed status, also the information get from the IoT sensors to the Amazon SNS. And the Amazon SNS will notify its subscriber with those information, which is the hospital management. And now I'm going to present the Lambda function. Now we are on the management console, and we can see that we have a trigger object, which is the S3 bucket, and we can see that when there is an object that new uploaded to the S3 bucket, and it will trigger this lambda function called lambda recognition. And once the lambda function is triggered, and it will run the code written here. After the code is done, then it will go to the destination, which is our second function. The code written here for this line, we actually asking the function to search for the first or the latest object that stored inside the S3 bucket. And once the object is get, and we will uh, pass into the recognition for detecting labels. And this client detect labels will process the image that we selected just now, which is the latest image, and it will process with those image processing, and the batch status will be predefined as unoccupied, and we are finding the word person in the labels. So when there is the person word found in the labels, and the batch status will be changed to occupied, which means that when the image detected there is a person inside the image, and the batch status will be occupied. If not, and it will be remain unoccupied. After we have get the batch status, and we will put inside a JSON with the timestamp together, and we will invoke these two information to the second function, which is my lambda function, and invocation type is event, and the message we are passing is the batch info JSON, which is status and timestamp. After the code is complete, and we will go inside to the second function, which is my lambda function. The main purpose of the second function is to combine the two information that get from different sources, and also make sure the data or the information is correct. In this part, we are trying to confirm that when the bed status is occupied, and we have to make sure the pressure and the temperature that we get from the IoT sensor is also verified. This is occupied data. For example, if the status is occupied, and we have to make sure the pressure is greater than 14 and the temperature is greater than 29, and that is a confirmed valid result, or else it will be an invalid result. And same as the unoccupied status, we have to make sure the pressure is lower than 15 and the temperature is lower than 30, so that we can make sure when the bed is unoccupied and the both value is correct, and that is a valid result. Once we have done the information checking, and we will start to send the SMS message to the simple notification service. The message included in the SMS message will be the bed status, timestamp, and the bed ID, and temperature, pressure, and this is the data information confirmation message, which will represent the valid result or invalid result. And this SNS is the function that publish the message to the SNS, which is the bed info SNS. And we can see here at the SNS, we have a topics called bed info SNS, and we have two subscriber, which is two email. We're using two email as simulation that the hospital management the way to get the information from the bed monitoring system, so that they could get the information that get from the IoT sensors and also the camera. And other than that, we have another database that store all this information, which called bed table, and it will also storing the status, timestamp, bed ID, and temperature, pressure, and also the information confirmation message. And we will put the item information onto the DynamoDB, and we can show here, which is we can come to DynamoDB, explore item, and bed table. So we can see that those information is the result that we test before, and we have a timestamp, bed ID, with the message valid or invalid result, and pressure, the bed status, and also the temperature. For example, we can see that in this timestamp, the bed ID is bed number 2, and with a valid result that when the bed status is unoccupied, the temperature is below than 30 and the pressure is below than 50. And so we can see that the result is true. And we will be clicking the test in the first function. We can see that the bucket has received a new image, and click on the second function. Then we will get the SNS notification because this email is the one of the subscriber of the SNS, so we can get the information which is bed status is occupied and the timestamp. Bed ID is bed number 1 and temperature is 35, pressure is 15, and the message is valid result. That's all for my part. Thank you.
Hi, my name is Tae Boon Yin. Now I will present the demonstration of the IoT core part. Now first let me explain my part in the architecture diagram. First, from the left hand side IoT device, it will capture the data like ID, temperature, pressure, and timestamp and send it to the IoT core. After the IoT core receives the data, it will send it to the IoT analytics to process. After that, the AWS QuickSight will get the data from the analytics and visualize it as the graph. At the same time, the data will also save to the Amazon S3 storage from the IoT core and send it to the Lambda to process. At the end, after the process, it will notify the user through the Amazon SNS to check the status of the bed. Now, in this assignment, we use Node-RED to simulate the IoT device from the bed monitoring system. So first, this is the function to get the bed data, and it will publish to the MQTT broker topic, and then also it will capture the bed picture and send it to the S3 bucket. So now, let's start the demonstration. In AWS IoT core, we have created a things called bed, and then we also set the rules, which is bed analytics, which is send the data to IoT analytics and save data to S3. We also attach the policy, which is allowed the our things called bed to receive the data from MQTT broker. So now, let's test the link between the Node-RED and IoT core. So we enter the topic and subscribe. Now we trigger it. Now we can see that the IoT core has successfully received the data from Node-RED. Now go to the IoT analytics. In IoT analytics, the bed data will go through the channel and store it in the data store. We can see that when the message come in, inside the channel graph, so we can see that the incoming messages and also store in the data store. After that, we can run the data set. It will extract the data from data store and generate a data set. After generate the data set, the AWS QuickSight will use this data set to create a visualization of the data with the graph so that the user can understand and analyze easily. Beside that, the bed data in IoT core will also save into S3 storage, which is the bed state bucket, and send it to the AWS Lambda to process. After the process, it will notify the user through the SNS for the bed status. So this is the bed stat that will save into the bed stat bucket. So after I trigger this, I will receive a AWS notification message that contains the bed status. That's all for my part. Thank you.
In conclusion, smart hospital using IoT cloud solutions have the potential to revolutionize healthcare by providing personalized care, reducing costs, and increasing efficiency. Healthcare organizations can leverage the power of IoT and cloud technologies to improve patient outcomes and provide a better quality of care. That's all for our presentation. Thank you.